Welcome to day 30 of our 62-day low-level design course. Today we are going to build something very practical, very real world, the low-level design of a hotel booking system. By the end of this session, you will not only understand how to model such a system, but also how to think through requirements, scope boundaries, relationships between entities, and how to structure your classes cleanly, applying solid principles and design patterns. This session will set the tone for designing larger, more complex systems later on. Let's jump in. Let's first see the objectives clearly. We will start by understanding the problem statement, what a hotel booking system needs to do, and what constraints it must satisfy. Next, we will carefully pick out the core entities, the things that will exist in our system, and the relationships between them. We then translate that into a visual class diagram that captures structure and behavior. After that, we will focus on the most critical classes with sample code outlines. We will also discuss how to use solid principles throughout and identify fitting design patterns. Finally, we will leave you with some exercises to deepen your understanding. This journey is going to be very hands-on and practical. Alright, let's dive into the requirements. When you think about a hotel booking system, imagine yourself as a user first. You open a website or an app and you want to find hotels in a particular city for certain dates. You might have preferences, maybe you want free Wi-Fi, a pool, pet-friendly policies, or breakfast included. So the system must allow users to search for hotels using multiple filters. They must be able to view hotel and room details, prices, amenities, photos, reviews. And of course, users should be able to book rooms and later cancel if needed. Now, from a non-functional angle, the system must be fast and responsive. Imagine hundreds or even thousands of users searching and booking simultaneously. Scalability becomes critical. Also, we must maintain data consistency. We can't allow double booking of the same room, right? Finally, availability is important. The system should be up 24 into 7 without frequent downtimes. These are the high level requirements we will keep in mind. Before we start designing, it's critical to define what we are not going to cover. This is called scoping. If we do not set boundaries, the design could spiral out of control. So for today's design, we will not cover payment processing in detail, such as credit card payments or refunds. We will not design loyalty programs, user reviews, promotions, or coupons. We will also not worry about integration with external hotel providers like Booking.com APIs. Our focus is purely on the core flow, finding available rooms, booking them, and basic room arrangements. Now let's talk about the heart of our system, the core entities. User. This represents anyone who wants to search, book, or manage bookings. Hotel. This is a real-world hotel that users can book rooms in. Each hotel has attributes like its name, location, rating, and available amenities. Room. These are individual units within a hotel. Different rooms may have different types like deluxe, suite, or standard and different prices. Booking. This is the record that ties a user to a room for a specific date range and supporting entities like address for the hotel at location, room type, capturing properties like bed size, smoking or non-smoking, etc. Amenities like pool, gym, Wi-Fi, and parking. These entities will translate directly into our classes. Relationships. Now, relationships between these entities form the skeleton of our system. Each hotel can have multiple rooms. Each room can have multiple bookings over time, but at any given moment, for a specific date range, one only active booking should exist. That means we have to be careful about overlapping bookings. Each booking connects a user to a room with specific check-ins and check-out dates. Amenities can be either hotel-wide or room-specific. We need flexibility to model both. These relationships must be very clearly reflected in our design, both at the class level and in our database later. Here's the overall class diagram. Notice how the arrows and associations are flowing. The user class has a reference to booking. Hotels must have rooms. Rooms have bookings. And both hotels and rooms have amenities. Address is attached to hotel. This diagram acts as our blueprint for the code we will write later. It's like an architect's sketch before construction begins. Let's zoom into a few key classes. User will have fields like user ID, name, contact information, and a list of their bookings. Behaviorally, users should be able to search for hotels and make bookings. Hotel will have fields like hotel ID, name, address, star rating, a list of rooms, and a list of amenities. Hotels can add rooms, update room availability, and manage their profiles. Each class must follow single responsibility. It should only manage its own data and behavior, not others. Moving on to room and booking. The room class will include attributes like room number, room type, price, and a list of its booking records. It will need a method to check if it's available for a given date range, a critical function. The booking class will have a unique booking ID, the user who made the booking, the booked room, the start and end dates, and the booking status like confirmed, cancelled, or pending. Notice the strong object relationships here. The booking ties a user to a room, and the room tracks its bookings for availability checks. Before we code, let's discuss some practical considerations. Room availability. How do we efficiently check if a room is available during a user's selected dates? Hotel search optimization. How do we allow fast, filtered searches across thousands of hotels? Booking conflicts. How do we prevent two people from booking the same room for overlapping dates? Data consistency. How do we ensure that a room isn't double booked even under high load? By thinking through these problems now, we avoid rework later. Let's apply some solid thinking. Single responsibility principle. Split responsibilities cleanly. The room class should not handle user-related logic. Open closed principle. Our system should allow new features like loyalty points without changing core classes. List scope substitution principle. If we create specialized room types later, they should work seamlessly where room objects are expected. Interface segregation principle. Separate interfaces, booking related actions versus hotel management actions to avoid bloated classes. Dependency inversion principle. Services should depend on abstractions, not concrete classes. Booking service should depend on an iRoom repository interface, for example, following solid ensures long-term maintainability. Here are a few design patterns that will naturally fit. Factory pattern. Use factories to create new bookings or room instances instead of exposing constructors everywhere. Strategy pattern. For different hotel search filters, location, price range, amenities, we can easily plug different strategies without modifying existing code. Observer pattern. When a booking is confirmed, observers like email services or SMS services can get notified without tightly coupling them to the booking class. Using these patterns keeps our system extensible and flexible. Here's a sample code outline. Look at the hotel class. It has fields like hotel ID, hotel name, address, a list of rooms and amenities. It also provides a method search available rooms, date start, date end, room type to find available rooms matching the criteria. Similarly, a room class would have a method like is available, start date, end date to check for overlapping bookings. This code skeleton will evolve further as we add more real-world scenarios. For your hands-on exercise, try designing a hotel search service class that uses strategy pattern to apply different filters. Implement a feature that allows multi-room bookings in a single transaction. Think about handling concurrency, use locking transactions, or version control to prevent two users from booking the same room at the same time. Working through this will deepen your LLD skills dramatically. If you are up for an extra challenge, think at scale. Imagine you are building for a real-world company like Booking.com. They have millions of hotels and tens of millions of users. How do you implement caching to speed up hotel searches? How do you use event-driven design to send booking confirmation mails asynchronously? How do you partition your database to handle such a massive load? This kind of thinking separates a good designer from a great one. Today we moved step by step from gathering requirements, clarifying scope, identifying core entities, designing a class diagram, and drafting sample code. We emphasized clean code by applying solid principles and key design patterns. You now have a real-world template for designing booking systems and many other similar applications. Congratulations on completing this session. Next, we will start applying these concepts to even larger systems in the course. Great work today. See you in the next session.